welcome to another session of our class. In our last class, we talked about errors in measurement. Now, what are errors in measurement? There are errors or there are particular fluctuations in our measurements that will lead to a defect or a deficit in our results. Now, these errors need to be checkmated. If the error is above 30%, automatically you have to repeat the experiment. Now, the error may be due to the apparatus or the equipment you are using, which is called systematic error, or it may be due to you yourself carrying out the error, which is called a random error. Now, wherever error it is, you have to calculate the error as well as the percentage error to know if this particular experiment is good to go through or you need to repeat it. Now, at each step of an experiment, you need to calculate the error in your readings or in your calibration or whatever to know if you have to repeat it or you have to go through with it, so that at the end of the day, at the end of the result, you have an accurate or nearly accurate value. Now, in our last class, we talked about how to get error and percentage error when you have a reading or an experiment that has to do with addition and subtraction in your formulas. If you do not know how to do that, you go back to our playlist, you look for measurements of addition and subtraction, so you'll be able to go through the class and understand how to calculate errors and percentage errors, so your results will always be accurate. Now, in this class, we'll be dealing about errors in measurement in quotient, that's division, and multiplication. So we have it as let's say we have a question, we have a formula q equals to a b, or we have q is equal to a over b. Now, it's going to be very different from when you have q equals to a plus or minus b. It's going to be very different when you have q equals to a plus b or q equal to a minus b. This is what we did in the last class, a plus b minus b. Now, what if you have a times b or a divided by b, or maybe we have a times b over c? How are we going to get the error and percentage error in this particular question, which is what we're going to be telling us in this class. So if you have not subscribed to our channel, you do so right now. You subscribe to our channel. Also check our Facebook page, Learning Area. Our channel is Learning Area. You can see our phone number, WhatsApp phone number. You can chat us up on WhatsApp. If you have any question on error or percentage error, or any question at all in mathematics, physics, chemistry, engineering, technology, sciences, you can always ask us in the comment section or on any of our social media pages. So click the notification bell, also notification button and the bell, so when we post a new video, you'll be among the first set to get it. So let's hit straight into the class. So let's say, for instance, we have a square or a rectangle. For instance, we have a rectangle with sides A and B. So we have side A and side B. Now, if we are to get the error in this particular measurement of this rectangle A and B, let's know if our side B is accurate enough or side A is accurate enough to go through. We have to get the changes which may have occurred in this particular experiment. So we need to know if we actually made error during measurement. Maybe we're supposed to measure B at 26, I will measure it at 26.5, or measure it at 24.9. We need to know, or maybe we're supposed to measure A at a particular value, and maybe due to systematic error or random error, we made an alterations to be the change in B as well as the change in A. So we made an error to be change in B as well as change in A. We need to know how to resolve it, or how to know if this particular experiment is good to go through or we need to redo it. So now let's consider the multiplication of this particular area or this particular rectangle, which is the area. So let's say Q is equal to A times B, which is supposed to be our formula for this particular question. Now, if we are to add these our percentage errors in it, that means our A, which has normal reading of A which you've taken, plus or minus the error, the change in A, which is our error. Also, you take a reading of B, which is the normal reading of B that you've taken, but there's an element of error in it, that's plus or minus B, which is the element of error in it. Now, how do you know? How are you able to get the particular error in each reading? I've said it in my previous class on errors in measurement. So you have to go back to my playlist and check errors in measurement for you to know how to get this change in A and change in B. It's very simple. Just to look at your calibration or to look at your experiment, you will easily spot out the change in A and change in B. But how do you do that? You have to go to our playlist and you check the link to the playlist. The link to the video is in the description of this video, so you can easily click on it and you'll be able to see or watch how we get these particular figures. So if we are to put these into this our area here, we have that Q plus change in Q is equal to A plus change in A times B plus change in B. Since we are expanding this particular figure, then we are to use the addition. If, for instance, we are contracting, then we want to use the subtraction. But since we are expanding, we want to use the addition. So we have Q plus change in Q is equal to, multiply, open this bracket, we have A times B will give us AB. A times change in B will give us plus A change in B. Then A change in A times B will give us plus B change in A. And change in A times change in B will give us plus change in A change in B. If you don't know how to open bracket, you check our playlist. We have a video on how to open bracket, how to expand, so you'll be able to do this effectively and without stress. Everything is in our video, so you just have to go through our playlist. You see the video there and you dive right in. So we have Q is plus change in Q is equal to, now AB, we know AB is what? From this play, AB is what? Q. Because this is also equal to AB. A times B is equal to AB. So we have AB here, we have AB as Q. Automatically, we can replace this AB with Q here. We have plus A change in B plus B change in A plus. Now, when we have the product of two changes, it's always insignificant. When you check some of our videos, we do something like this, especially in our calculus. When you have the product of two errors, automatically it gives us an error. So it's always insignificant. That means we consider this to be 0. So no matter what the value is, it's going to give us 0. So that is insignificant. So we have this. So next is to collect like terms. Let's take all the Q's to one place, as well as all the A, B, whatever to another place. So we have Q. This Q comes this way. Since it crosses the equality sign, it becomes minus Q. Because this Q cross equality sign here, because the sign changes from plus here to minus, becomes minus Q. Then we have plus change in Q. Then we have equal to, we have this left here, A change in B plus B change in A. So Q minus Q automatically will go off. We're left with what? Change in Q is equal to A change in B plus B change in A. So the next is to divide both sides by Q. I told you in one of my videos, or most of my videos, that whatever I do to the left hand side, always repeat it to the right hand side, so that it will be mathematically correct. If you do something to the left hand side and you don't repeat to the right hand side, automatically you are wrong. But if you do something to the left hand side and you do it to the right hand side, everybody will know you are actually correct, because you've done it to both sides. So if we are to divide this change in Q by Q, which gives us our error, or our percentage, or our percentage error, as we have said in our previous video, then we'll do the same thing to our right hand side. So we have it as change in Q over Q is equal to A change in B over Q plus B change in A over Q. Now we have this. Remember, our Q is equal to what? AB. So we can replace this our Q here as AB. It's still going to work. So we have it as change in Q over Q is equal to A change in B over AB plus B change in A over AB. So automatically this A can go with this A, and this B can go with this B. Now this B cannot go with this change in B, because they are two different things. One is change in B, while one is B. Or this is change in A, while this is A. So they cannot actually cancel each other, but A can cancel A and B can cancel B. So we're left with the change in Q, which is our error, is equal to change in B over B plus change in A over A. So you see, that's the formula for calculating error in our quotient or our multiplication. If, for instance, we have something like Q is equal to A squared over B, for instance, then we'll have, okay, let me write it down. Let's say, for instance, we have Q is equal to A squared over B. That means our error is going to become change in Q over Q is equal to 2 change in A over A plus change in B over B. That is just the formula to calculating the error in measurement when we are dealing with quotient and division. So we'll see an example.